Okay, what we're going to do here is sketch the graph of y equals 2 over pi tangent inverse x. And to start this, what I'm going to do is I am going to sketch quickly, hopefully, I'm going to quickly sketch the graph of y equals tangent inverse x. So this is not just tangent inverse x, it has 2 over pi multiplied there. And so here I go. What I'm doing is I'm drawing the horizontal asymptotes. So if you remember the graph of y equals tangent x, there are vertical asymptotes, and that cycle right in the middle, maybe called the fundamental cycle, has vertical asymptotes as x equals pi over 2 and x equals negative pi over 2. When we find the inverse, we swap x and y, and so now we get horizontal asymptotes. Where we had vertical asymptotes, we had horizontal asymptotes when we have tangent inverse. And pick a nice color if we feel like it, if we feel like that's a good idea. And so I'm going to go ahead and draw the graph. Okay, so this is the graph of y equals arctangent, or maybe I won't write arctangent. I'll write just tan inverse x. Now, one of the things I can do for this graph here is, or from the graph, I can sort of make a little mess of my picture, is I can plot a few points. Well, that might not be the best way to do it. So the question is, what happens when I multiply by 2 pi? So I'm taking all the y coordinates and multiplying by 2 pi, and these vertical asymptotes we can multiply by 2 pi. I'm going to have to make this a little smaller. So everything gets multiplied by 2 over pi. So what you can do is you can just jump in and just draw this and then adjust the scale. Because what's going to happen when you multiply by a number is it's just going to either shrink it or compress it or expand it vertically. So actually pi is around 3, so it's like multiplying by 2/3, so it's actually going to compress it. And so when I drew this, I'm not really doing the scale very well. Maybe I should though, but maybe I should keep the same scale. It might look better. So try to sort of get the idea. This is like multiplying this by 2/3. Okay, maybe I'll do that. It doesn't, that's the thing, once you get graph paper, then you start thinking, oh, maybe I'll get the scale really right. But see, okay, here I have y equals, this is my horizontal asymptote. I have y equals, well, before I had pi over 2, but I'm multiplying everything by a number. All the y coordinates get multiplied by the number. So tangent inverse output, you multiply by 2 pi. Now, it's true, the graph never reaches pi over 2, but still we can do that to get something. And here I have a horizontal asymptote, y equals negative pi over 2, and I can multiply that by 2 over pi, and that's equaling -1. So anyway, I get y equals -1 and y equals 1, and it really helps if we just understand, or basically understand the idea that what multiplying a function by a number does is it just compresses it or expands it vertically. So that's it.